let's start with 2015, day 18, and see what we've got. Like a gift for your yard. After the Million Lights incident, what's the Million Lights incident? Oh, that was day 6, I see. The fire code has gotten stricter. Yeah, so this was at that, what, 1,000 by 1,000? Yeah. And now it's 100 by 100. Never want to let you down. Santa again mails you instructions. Start by setting the lights to the included initial config, which is your puzzle input. Let's take a look at that. Get input 2015 day 18. Input 2015 18 text. Oh, okay. It's a grid. Interesting. Here's a simplified 6x6 grid. The state of the light should have... Oh, this is, right. Yes, I remember. This is Game of Life. There's something similar to this in every year, I believe, or at least almost every year. The light stays on when 2 or 3 neighbors are on, and light turns off exactly 3 neighbors are on. Oh, light that's off turns on if exactly 3 neighbors, and light is on, stays on for 2 or 3, and turns off otherwise. Okay. All of the lights update simultaneously. They all consider the same current state before moving to the next, right? And then we have a 6x6 example grid, so we can use that for testing. All right. So why don't we grab the initial state here, and then we got to figure out how we're going to store this. So start with updating the mod. Change this to 18. This becomes 18. This becomes 18, and then we have day 18. Okay. 2015, day 18. Very good. So we're going to need a grid. And I think the normal way to do this, I mean, the way I remember doing these in the past, is just using a hash set. And if the a hash set of tuples of coordinates, and if it's set in the coordinate, I mean, if it's set in the set, then it's on. If it's not set in the set, then it's off. So we'll pull in the hash set. We'll add that to it. Ooh, I don't want to do that. That's not good. I didn't realize that 18 would be considered part of... Let's do this. There. Okay. So we just have a grid, and it's going to be a hash set of usize. I'm assuming this doesn't go negative. Or I guess we get to define what it looks like. And then here we just create it. Grid. Hash set new. And this should just be unsolved when we try to run. Oops. Okay. Did I mess this up? I did. All right, very good. All right, so all we need to do now is in parse, we can just use test data and do it this way. So let's just create this. Oops, I don't want that. I want to hit copy here, paste over here, and then just create, oops, like this. Create strings, and then create that to string. So what I'm going to do is I'm just simulating the input that we're doing, and then let test data equals this. Yeah, that should be fine. Right, and now we can just parse it, and then all we have to do to get the real data is we just change the parser, not this for loop line, for line in test data, and this will become for line in AOC lib read lines input 2015 18.text. Right? Okay. So now all we need to do Oh, so we're going to need to know the size, right? I guess not. I guess we can just say for row. No. We're going to set them here. Let row equals 0, let col equals 0, and then we can just increment them as we move along. So now for C in line.chars, if matches C with this, then we're going to insert it into our hash map. So this is going to be our grid. Oh, yeah, we have it already. So self grid insert row col. We increment col, and then we increment row. And that should be it for getting the grid in. And then we can just say here, println. Should we write a little display function for it? Or debug? I'm just trying to think of the best way to... I can just say self dump, and that'll just write it out. I don't have to write, that way I don't have to write a trait or implement a trait for it. So we can just write pub or fun dump self. And now we need to know how many rows there are. So we're going to need self rows and self cols. Rows, size, cols, size. Right, for R in row, self rows, for C in self cols, print, if self grid contains RC, then we're going to say print hashtag, otherwise we're going to print a dot. This is all basic stuff I've done 100 times, that's why I'm just rushing my way through it. But we need to know self rows and self cols. We need to actually set those. So rows, let's start at 0, cols start at 0, and then I guess at the end of this loop we'll know, right? Self rows equals row, self cols equals col. Right? Because this gets, this has to be reset to 0 at the beginning of the loop. Right? We don't want to set it at the end of the loop when we increment row, because then it'll be 0 here. So if it's set at the beginning of the loop, then col will be what it needs to be. So let's try that and see if this prints out anything. Oh, col. Still 2 errors. Oh, 0 dot dot self rows. There we go. See, I shouldn't have been rushing through it. All right, and then I forgot the new line after the. Okay, but let's see. Does this look like this initial state? Oh, I can't move this window. There we go. Yeah, that looks correct. All right. So the next thing would be figuring out how to take one step forward, right? And that's where all these rules come in. All these rules meaning these 2 rules. So let's write a step function. Step. And it's going to modify self. What we need to do now is we need a function which can tell us how many neighbors are on. Right? Because if it's on and we have 2 or 3 neighbors on, then we stay on. Otherwise, we turn off. Light is off. A light which is off turns on if exactly 3 neighbors. So we need to check each one. So we need, just like before, R in 0 self rows for C in 0 dot dot self cols. And now we have to say if it's on, if self grid contains, we need the next state. Next state is hash set new. Oop, that was weird. And then after these for loops, which aren't lining up because of I didn't finish the if statement, we're going to say self.grid equals next state. And that'll give us one move. All right, self-grid contains row column. Then we're going to check to see, how many neighbors are alive. Let neighbors equals self-grid, no, self-neighbors. I'm just going to make it a separate function of R and C. That way it doesn't mess this loop up and we can just check it. If it contains, if it's on, then we're going to see how many neighbors there are. If 2 or 3 neighbors are on, it stays on. And otherwise we turn it off. If neighbors equals 2 or neighbors equals 3, then our next state, insert RC. Right? So this way we're saying if there are 2 or 3 neighbors on, and this one's already on, then our next state, it's going to be also be on. We only have to put it in if it's on. If it doesn't contain, if our current grid doesn't contain that value, in other words, light is off, it turns on if exactly 3 neighbors are on. So we can say else it's off, so we can say else here if neighbors equals 3. Next state, insert RC. So we can actually simplify this a bit. We always turn it on if neighbors are 3, right? So we can do that right up front. We could just insert it, except I misspelled insert. Right, next state is, if neighbors is 3, we always insert. Otherwise, if it contains and neighbors is 2, then we insert. Right? I think that's the correct logic, and we can try that out. So what we can do here is we can say self dump, and then we can say println dash self step self dump, and that way we can see if we go one step, does that show up there? Of course not. Oh, because I haven't written the neighbors function yet. Okay, let's write that. Self row usize call usize. So the way this works is we're just going to add up for R in row. I don't want to say row -1, but we can use modulo arithmetic to do it, right? Self rows +1 mod self rows. That's -1, right? And then -1, 0 is row, and then column is row +1. And then we can, I mean, the last one is row +1, and then for column in, and we can use the same logic, right? Except replace row with col. I think that'll work. And then all we're doing is counting how many neighbors there are. And so we're going to return that. Size. Let count equals 0. If, oh, we want to skip it if, we want to skip the middle one, right? If R equals row and C equals col, continue. Else if self grid contains Kafka says self rows +1 mod self rows is always 1. Oh, right. I think I have to do this, right? Wish there was some way quick I could do this, Python. Rows equals 12, row equals 8, and now say print row plus rows plus 1 mod rows. That's 9. Yeah. So if I say print row plus rows plus 1 mod rows, that's also 9. Oh, I guess I could just say -1, right? Why can't I do -1 here? That's 7. There we go. Okay, that's what it is. Thank you, Kafka, for making me check that. So we want -1 here. If self-included contains row column, then we're going to add 1 to count, and then just return count here. Like that. Okay, let's see if that works. Nope. What do we got here? Next state, expected tuple found usize. Oh, because I'm inserting, I don't want to insert it with the ampersand. And of course, I forgot to put mute there. All right, let's see if that works. Okay, it doesn't work. You can see that this is failing here miserably. After one step, it should look like this, and it doesn't. All right, so maybe this logic is still bad. We can print these out. And see what it looks like. For row like that, and then see what it shows us. So for 0, we have 5, 0, and 1, right? 1, 2, 3, 4, 5. Yeah, that's right. For 1, we have 0, 1, and 2. For 4, we have 3, 4, and 5. And for 5, we have 4, 5, and 6. That shouldn't be. Oh, because row plus 1 has to be mod as well. Calls. All right, let's try again. It's still wrong. All right. Let's try one more time with this thing here. And that. 5, 0, and 1. That's correct. And 4, 5, and 0. Okay, so I think we're calculating these numbers correctly now. It's just that we're not doing this part right. Do I have all these correct? This wasn't supposed to be the hard part. I can just print out how many neighbors are alive for that. Println row call equals count. All right, let's try. 0, 0 has 4 alive. That's wrong, obviously. Huh, okay. Why does it think 0, 0 has 4 alive? Oh, because it shouldn't be wrapping. This grid is not a wrapper grid. Okay. All right. That's why. Got it. This is for if we're wrapping around, like if this neighbor is attached to that neighbor. But I think we just have. I don't think it wraps. They didn't say it wraps or not, so I assume it doesn't. So then what we need to do is come up with a check function, which is given a row, or given a position and a limit. It'll return a vector view size, and which just would be the things we need to check for that particular one. So if position is 0, then we're going to return a 0 and 1, because that's all we need to check. If position +1 is equal to the limit, then we're going to just check, we're going to check just position -1 and position. Otherwise, we're going to check all three, vec of position -1, position, and position +1. All right, get rid of all this. And then we can say for R in check row, self rows, and for C in check call self calls. Yeah, and this stays the same. All right. Let's see if that's closer to what we need. Self check. Self check. There. All right. Let's see if that's closer to what we're looking for. Yeah. Okay. That's it. That's it. Much better. All right. That took annoyingly long. But now we just need to run the steps, right? And so we could ignore all this stuff. In a grid of 100 by 100 lights, given your initial configuration, how many lights on after 100 steps? Okay, so this should be the easy part. Let's put this line back. And then comment that out. And then put an underscore here. And now I don't want to do a dump step dump. What I want to do is say 100 steps, or in 0 on 100, self step. And then we want to just count how many lights are on. So we say create an output self grid len. We got a warning because dump isn't being used. It says 1906. Let's see if that's right. That seems really low, doesn't it? Oh, your answer is too high. I figured with a grid of 100 by 100, we'd have more on, right? 100 by 100 is 10,000, and only 20% of them are on. Maybe that makes sense. All right, let's do multiple steps with the test data and then see if something goes awry there. Oh, no. That's my mistake there. I said 0 to a 10. Let's try 0 to 100. All right, we got 768 this time, and it's probably too soon, right? 12 seconds. All right, we just need to wait 12 seconds. Let's see. Dump. We'll change this to an underscore so that Clippy doesn't complain. Let's check with Clippy. Oh, this if has identical blocks. Oh yeah, so we could make it neighbors 3 or that makes it harder to read, I think, right? Or this. We insert there, right? Okay, and now run. Wow, that was a lot slower. It took 6 seconds that time. All right, still 768 though. That's good. All right, good. That was the right answer. What's part 2 going to be? Go to 1,000? You flip the instructions over, Santa goes on to point out that this is all just an implementation of Conway's Game of Life, right? 4 lights, 1 in each corner, are stuck on and can't be turned off. The example above will actually run like this. Oh. Okay. And this is part 2. So in part 2 is going to be identical to part 1, except we're going to turn on the corners before doing the step. Self grid, insert 0, 0. Then 0 self rows -1, and then self, oh no, that was supposed to be calls. And then self rows -1, and then self rows -1, and self calls -1. All right, so we turn on each one of the corners, and then we run the step, and then we output that. What do we got? Unsolved. Oh, it's still computing. Okay. Oh, it's slow. What did I do differently? I thought it was faster last time. 594. Oh, now the answer is too low. Okay, what's the oh, I know what the problem is. We have to reset the grid. Because we ran it for part 1 and now it's completely different. So that means we need to do either reread it, reparse it, or save it in initial grid. And we can do that. Parse. And then we can just say self initial grid is equal to self grid clone. And then we just set the self grid is equal to self initial grid. We don't have to clone it because we're not going to run it again. And we don't have initial grid. It doesn't like this. Oh. Typoed it. Move occurs. Yeah, that's what I want to do, but I guess we can't do that. All right. Let's see what this does. Yeah, this is weirdly slow. Kafka says, I usually don't give the part methods write access to the initial input. Yeah, I mean, most of the time that works fine, right? But in this case, I needed to fiddle around. So the answer is too low, so we have a bigger number now. And it's still not the right answer. What did I do? I guess we can try it with the test data and see. And then step dump, self dump. Oh, underscore dump. Oh, we don't, I didn't want to dump it out 100 times. Oops. I just want to do it 5 times. Or 6 times. But, oh, I'm not using test data. Yeah, let me use the test data. And I need to put a line between each one. Otherwise, everything blends together. Okay, so where's part 2? Okay, that's part 1. 4. That seems wrong. Oh, no, that's right. Yeah, there's 4 left on. So part 2. Oh, you know what? I have to return on... yeah, Kafka says test only does 10 passes. We didn't have to do all 100. But I forgot to turn on these 4 elements before counting. So I think maybe, what's the right way to do this? I mean, the quick and dirty way is to just duplicate these things, right? And that way, but I don't like duplicating the code. There has to be a cleaner way to do this. So let's change this back to 100 now. Let's do the real data and then see. So here we turn them all on, we do a step, and then we turn them all on again, and then we generate the output. So I think that was what I was missing out of the other one. So 781. So I was off by 1. There we go. All right. And then test data. All right. Clippy. Oh, I forgot to save it there. Okay. Let's put that there. All right. Is there a better way to do this? I don't know. Maybe the step. Maybe the step should get an argument saying whether or not to turn on the corners at the end. But then we still need to turn them on at the beginning. So, I guess this is good enough. This is good enough. And at some point we want to extract some of this code and make it, put it in the library, because this is going to be used a few times. The Game of Life kind of stuff with twists. All right. Well, we got day 18 done. Let's commit these changes. Git status, git add source and input, git commit 2015 to 18.